In Module 5, Section 4, we will be adding and subtracting polynomials. To add polynomials, we simply combine all like terms. Let's try an example. Here we want to add the polynomials 3x minus 8 and 4x squared minus 3x plus 3. To add, the first step is to drop all parentheses, create one large algebraic expression, and then combine the like terms involved. When we combine like terms, typically we can start with the first term, find like terms, and once we combine them, we will cancel them out or cross them out. So starting with 3x, we look for other terms that also have an x. We find negative 3x. Once we have like terms, we combine the coefficients. 3 minus 3 is 0, so we will have 0x. I typically would not write this because 0x is just 0, and 0 adds nothing to our problem. But just to show where the x's go, let's write the 0x down. Looking at the next term, negative 8. Negative 8 is a constant term. As we go through the problem, we find that 3 is also a constant. Negative 8 plus 3 is negative 5. We can cross through those terms. The only term left in the algebraic expression is 4x squared. 4x squared doesn't have any like terms, so we just copy it verbatim to the next line. Now to clean up the like terms that we've created, 0x is just 0. We don't need it in the solution. We're left with negative 5 plus 4x squared, which could also be written as 4x squared minus 5. The order really doesn't matter for this section. In the next example, let's add 8y cubed minus 4y squared plus 5 and 5y squared plus 1. Because we are adding polynomials, we need to create one large algebraic expression where we are going to combine like terms. Just like before, we can start with the first term and then look through the expressions to try to find a like term. Here we have 8y cubed. We can see that there are no other y cubes in the problem. So on the next line, we'll write down 8y cubed, and in the algebraic expression, we are finished with that term. We go to the next term, which is negative 4y squared. As we go throughout the expression, we find another y squared term, 5y squared. We can combine the coefficients. Negative 4 plus 5 will give us a positive 1, or just y squared. As we continue, we have a 5, which is a constant term, a 1, which is also a constant term, and 5 and 1 will add together to give us 6. And at this point, we are finished. Similarly, to subtract polynomials, we will first change the signs of the terms of the polynomial being subtracted, and then we'll add the two polynomials together. So let's try a subtraction example. 7x minus 8 minus the polynomial 3x minus 12. The first step should always be to distribute the minus sign to the polynomial that is being subtracted. And when we do that, that will change the sign of every term in the second polynomial, or the polynomial that's being subtracted. Once we do that, we can drop all other parentheses. So we're left with 7x minus 8. When we distribute the minus sign, it gives us minus 3x, and the minus 12 becomes a positive 12. Now this should look very similar to the addition problem. The only difference is we have changed the sign of every term in the second polynomial. So going through a similar process, we start with the first term, 7x. We find other x terms. Here we have a negative 3x. When we combine the coefficients, 7 minus 3 is 4, so we're left with 4x. We're finished with each of those two terms. We go to the next term that's not canceled out, is a negative 8. That is a constant term. 12 is also a constant term. Negative 8 plus 12 is a positive 4. So we're finished with those two terms. We've used every term in the original algebraic expression, and we are finished. In the next example, we are also subtracting two polynomials. So remember the first step. is to move the minus sign through the polynomial that's being subtracted in order to change all of those signs. As we do that, we will drop parentheses, and that will give us 2x cubed plus 8x squared minus 7x. Now, in the second polynomial, we change signs, so minus 3x cubed plus 2x squared minus 3. Once we have one large algebraic expression, we combine like terms. So we start with the 2x cubed. As we go through the problem, we find another x cubed. Combining those coefficients, 2 minus 3 is negative 1. So this becomes negative x cubed. And we can cross out those terms because we've used them. The next term we have is 8x squared. Going through the problem, we find a 2x squared. 8 plus 2 is 10, so this becomes plus 10x squared. As we continue to go through the problem, we find a minus 7x. But there are no other terms with an x to the first power. So we just copy that minus 7x down to the next line. The only term we haven't circled or crossed out so far is the minus 3. It is a constant term. There are no other constant terms. So we copy it down to the next line as well, and we are finished. Let's try these examples. We're told to add or subtract as indicated. In example A, we have 4 minus the polynomial negative y minus 4. Just like any other subtraction problem, we move the negative sign through the polynomial being subtracted first, and then combine like terms. So this will become 4, negative y becomes plus y, negative 4 becomes plus 4. The only like terms we have in this example are the 4's. So the answer will be y plus 8. 4 and 4 make 8, the y just comes along. In the second example, we see we have 3 polynomials, and we are doing both addition and subtraction. In this particular case, we just need to make sure that the minus sign goes to the polynomial that's being subtracted. Then all parentheses will fall off, and we will combine like terms. So this will become negative a squared plus 1 minus a squared plus 3 plus 5a squared minus 6a plus 7. At this point, we start with the first term and find all like terms that we can. So we start with a negative a squared. We have another negative a squared. As we go further, we have a 5a squared. We combine all of those coefficients. Negative 1 minus 1 plus 5 is a positive 3, and the variable stays the same. Neither variable nor exponent change when we're adding like terms or subtracting like terms. We go to the next term that isn't canceled out. We have a positive 1, that's a constant term. Positive 3 is a constant term, and so is positive 7. 1, 3, and 7 will give us plus 11. And now we see the only term that has not been canceled so far is negative 6a. It has no like terms. We write down minus 6a on the next line. We're finished with all of the terms in that algebraic expression. And this is the answer, 3a squared plus 11 minus 6a. That can be written in any order you choose as long as the signs for each term are correct. Let's try another example where we are told to add or subtract. And we see from the sign in between polynomials that we are adding. Because we are adding, we simply drop the parentheses and combine like terms. So this will become 3x squared minus 7xy plus 8y squared minus 2x squared plus 9xy minus y squared. Starting with the first term, we have a 3x squared, so we're looking for other x squareds. We'll find a minus 2x squared. 3x squared minus 2x squared will become 1x squared, or just x squared. Going to the next available term, we have minus 7xy. We find a positive 9xy as well. Those are like terms. When we combine the coefficients, that will become 2xy. Going to the next available term, we have 8y squared, and at the end we have a minus y squared, or a minus 1y squared. 8 minus 1 is 7, so that will become plus 7y squared. We've used every term in the algebraic expression, and our simplified answer will be x squared plus 2xy plus 7y squared. In the next example, we are told to subtract. And remember, the first step in subtracting is to move the minus sign through the term, or through to the terms that are being subtracted. In doing so, all of those signs will change. So we drop parentheses, and we are left with 9a squared b squared plus 7ab minus 4ab squared. Now remember, in the second polynomial, we changed the signs. So we have minus 6b squared a minus 3ab plus 4 plus 10b squared. Just like before, we start with the first term, find like terms if we have them, and we continue to combine. So we start with 9a squared b squared. We look for other terms that have an a squared b squared, but we find none. So on the next line, we write 9a squared b squared, and we're finished with that term. We then go to the next available term, which is 7ab. So we look for other terms with an ab, and we find minus 3ab. We then combine the coefficients. 7 minus 3 is a positive 4, and the variable stays the same, ab. Moving right along, we find minus 4ab squared. So we're looking for other terms with an ab squared. And although it doesn't look exactly the same, we find minus 6b squared a. Remember, the order of the variables is irrelevant. Each of these terms has an a, each of these terms has a b squared. So these are like terms. We combine the coefficients. Minus 4, minus 6 make minus 10. And conventionally, I write the variables in alphabetical order. So I would keep the form ab squared. We go along and we find 4, which is a constant term. There are no other constant terms, so we write plus 4. And at the end, we are left with a 10b squared. There are no other terms with just a b squared for the variable, so we copy down the 10b squared as well. We've used every term in the algebraic expression. This is the simplified subtraction problem. We can also add or subtract polynomials with fractions. We go through the same process. Just remember, with fractions, when you add and subtract, you need a common denominator. So because we are adding, we drop the parentheses. We have 6 over 7 m squared minus 3 over 8 m plus 6 over 7 minus 1 over 7 m squared minus 1 over 16 m plus 1 over 14. Starting with the first term, we have 6 over 7 m squared, so we're looking for other terms with m squareds, and we find a negative 1 over 7. These two terms already happen to have common denominators, so we can go ahead and combine these terms. 6 over 7 minus 1 over 7 is 5 over 7. The variable stays the same. We go to the next available term, which is negative 3/8 m. And the next term we find with an m is negative 1 over 16 m. Now, because we do not have common denominators, I'm going to just write these beside one another. The plus that I'm putting here is just a placeholder because we aren't finished combining these like terms yet. I will cross through those in the original expression just so we don't try to use those again. Next, we have 6 over 7, which is a constant term, positive 1 over 14, which is also a constant term. But because we don't have a common denominator yet, I'll put another placeholder to show that we're not finished combining these like terms. Now, as we go through, the 5 over 7 m squared, that term comes down. And the next set of parentheses, the least common denominator will be 16. So you can, off to the side, change each fraction so that it has a denominator of 16. I'm just going to go ahead and write that down, what that would become. That would be negative 6 over 16m minus 1 over 16m plus, with the constants, here the LCD will be 14. So if you need to, off to the side, work each fraction, create equivalent fractions that have denominators of 14. I'll just do that in one step. This becomes 12 over 14 plus 1 over 14. Remember, that's a skill we learned back in Module 1, so we don't need to spend too much time explaining each Module 1 step in the process. So we copy down 5 over 7 m squared. When we combine the numerators with the m terms, this becomes minus 7 over 16m. When we combine the numerators with the constant terms, we have 13 over 14. And for the last example, let's use addition and subtraction of polynomials with a few of the word problem operators that we've seen before. We want to subtract 5x plus 5 from 7x squared plus 9x plus 8. Hopefully you remember, and we saw this as early as Module 2, whenever you see subtract from, we need to reverse the order. If we do not, we will get the answer wrong every time. So this is definitely a subtraction problem. We don't write it in the order in which the terms are presented. We write the 7x squared plus 9x plus 8 first, minus the first polynomial that was written, 5x plus 5. Once we have a subtraction problem, we distribute the minus sign to the polynomial that is being subtracted, and then we drop parentheses. We have 7x squared plus 9x plus 8 minus 5x minus 5. Starting with the first term, we have a 7x squared. No other term has an x squared, so we copy that to the next line. The next available term is 9x. The next term with an x is minus 5x. So we combine those. 9 minus 5 is a positive 4, and the variable stays the same. The next available term is 8. That is a constant term. So is minus 5, or negative 5. 8 minus 5 is a positive 3.